Hi, welcome to tutorial number 13 for CSCI 130 Introduction to Programming here at the University of Wisconsin Parkside. Today we are discussing some important concepts from chapter 7 from your textbook about algorithms, pseudocode, and if statements. Um, the first part in our book they talk about the concept of structured programming. This is important for programmers because this will help us to identify blocks of code. For example, on figure 7.23, if you see lines 18 and 21, the if and the else and 27, they are on the same column. However, 19 and 20, the code is there's some indentation and that is shifted to the right of the if statement. So that is with the idea that we identify that 19 and 20 belongs to the part when the if statement, the hours, the variable hours less or equal than hour limit, it is true. We execute lines 19 and 20. So this helps our eyes, let's see, humans, to identify, oh, this is the statements that needs to be executed in that case. While 22 to 26 will be the ones that will be executed otherwise. That means when hours greater than our limit, then we're gonna execute 22 to 26. So that indentation help us to identify that those segments, those blocks of code, and you see on 27 is also on the same column, so that means it's the same, the same, the ending of the statement. So this is not important for the compiler, for the computer. This is something to help us. So this is what we call structured programming. It's just the way that we organize the code, so it's easy for us when we need to go and fix something and understand the blocks. So we use that type of indentation. Now when we're actually solving a problem, we need to have a strategy when we're gonna solve the problem, and that's what we call an algorithm. So this is the part where we use some critical thinking and we design a strategy to solve the problem. So just by knowing the language and the commands and the instructions is not enough to solve problems. We need to come up with a strategy to the way of solving a given problem. Like in the textbook, for example, they're gonna say, oh, let's suppose that we need to compute the salary for an employee, and whoever works more than 40 hours per week, we're gonna give them pay them overtime, but they're gonna earn more than the base salary. So they give us the problem, they want us to design a program, so we need to come up with a strategy, with an algorithm. What is it that we're going to do? What are we going to ask the user? What are we going to do with the data that the user provides? How are we going to display the input? And the way that we solve the problem is, first we need to figure it out, in our mind, how we're going to do it, and that's what we call an algorithm. And that is going to be the steps that we're going to use to solve the problem. Now we sometimes write those steps using some type of pseudocode that says, okay, I'm gonna be doing this as a step number 1, and then a step number 2, but we mix that language with some type of statements that look similar to the computer language. Like for example here, assign 0 to the counter. So we're talking about variable counter and we're making an assignment. So we're combining an explanation and mixing with some type of code. So that's what we call pseudocode. This is some people likes to do that, and it's easier for them when we're designing the strategy. Okay, now the main thing about this chapter in this week is about making decisions, and we do that with what we're gonna call if statements. Now in our previous week examples, we were executing programs in a linear way or a sequential way. That means step number 1, number 2, number 3, and in statement 1, then we execute statement 2, then statement 3, and then the program ends. What we're gonna be doing now is, okay, we're doing statement number 1, statement number 2. We're gonna transfer the control to something else. Like, okay, number 4, I'm gonna take a decision. Should I execute 5 or should I execute 7? And then if I'm gonna execute 5, then what we're gonna do is transfer the control from there to 5, and then from 5 maybe we go to number 8. So we're not following a sequence of 1, 2, 3, 4, 5. So we're gonna execute the statements in a different order. That's when we need to make decisions, because okay, we're in number 4. Now what should I do next? Okay, so in Visual Basic they say that there are 3 types of statements. The if-then statement. The if-then statement is, if this condition is true, then execute this. That means this is an optional statement, or a statement that only will be executed when certain condition is true. The second type is an if-then else. If-then else, they, like in the one that I show you in figure 7.23, we're gonna execute either the part that is in between the if and the then, when the condition next to the if is true. If that condition is false, we're executing whatever is between the else and the and if part. So what is the difference? So in here is we're executing only one possible statement, and if this is false, we're doing nothing. I mean, we just continue with the program. So going back to figure 7.23, this is an if-else statement. Okay, and the third type is a select case statement, which may be multiple actions given a condition. So we check for the value of a variable, and then maybe there are 7 possible values for that variable, so there are 7 possible actions. So that's a multiple decision statement. Okay, so this is a good explanation of if-then selection statement. For example, here in blue, they have some pseudocode that says if student's grade is greater than or equal to 60, then display pass. So let's suppose that we have a program that we're asking for enter your grade from the user, and then if the user enters a grade greater than 60, that's what there is at the end of this slide. A student graded variable student grade greater or equal than 60, then on that label, that text display the text pass. Okay, now when we using if-then statements, again, maybe you have noticed that next to the if we have a variable, and then we're checking for a condition. Is the value of that variable greater or equal than 60? So we got some type of equality operators and relational operators to compare and to make decisions. So there is a table on the textbook on figure 7.4 where they have the operators. So this is, I mean, the ones, how do we say, greater, less, greater or equal, less or equal, and then the equality, how do we say that is different? So look at the symbol that they use when it's different. So it's the two symbols, the less than and greater than together, means it's not equal. Okay, figure 7.5 displays the basic format that we have an if. Next to the if we use a condition, then the keyword then, and then a set of statements that we execute. So we're only executing that statements that we can say that they are only executable if the condition is true. Now, like in the example that they just display, was the if the grade was equal to 60, then that was passed, but we didn't display fail. So here, then 7.6, the section in the textbook, they talk about the if else. So in the if else, if the grade greater than 60, well, okay, we know that we display that, but what about otherwise? That's the else part, then display fail, and that code illustrates that example. And this is the format for that. So there is an if, there is a condition that is either true or false, that evaluates to true or false. If that's the case, then we execute the statements next that follow the then statement. If the condition is false, then we execute the statements that are next to the else, between and before the end if. Okay, in your chapter they illustrate this concept with an application that says that this is a company that employees work 40 hours per week, and when they work more than 40 hours per week, they gonna be compensated with an additional $50 per, I'm sorry, 50% of the whatever they make per hour. So so this is the idea. For example, here they say that this employee, he makes $10 per hour. He worked 45 hours. Then the salary for the week should be 475. So what they do is for the first 40 hours is 40 times 10, that's 400. And for the overtime, the 5 hours, is gonna be $15. So it's gonna be 5 times 15, because they pay whatever is your hour. I mean, whatever you make per hour, they pay you an additional 50%. So that will be, instead of paying you 10, they will pay you 15. So that will be 15 times 575 plus the 400 for you 40 hours. Then you will pay 475. So what they want is that they want us to design an application that looks like this, and that's what I'm gonna show you on the, well, I hope this tutorial doesn't become that long, but I'm gonna show you this application, and that will be the end of this section. So I'm gonna do that on tutorial number 14, because I already spent here 11 minutes. So on the next one, I just gonna develop this and implement this code there. So then let's continue with tutorial number 14, I think.